Find the area of a circle inscribed in a triangle with side lengths of 5, 12, and 13. Now we know our triangle is going to be a right triangle because the side lengths are 5, 12, and 13, right? 5 squared plus 12 squared equals 13 squared. Okay, and since it's a right triangle, we have our little right angle indicator down there. Okay, now we want to find the area of the circle. And to find the area, we have to find the radius, right? Because pi r squared. So let's go ahead and draw in the radius to the center, and this radius down here, and we'll draw one out here to the points where the inscribed circle meets the triangle. Now remember, an inscribed circle, if you want a definition, is a circle that's drawn completely inside the triangle and is touching as many points in the triangle as possible. So in this case, it's touching 3 points, right? 1, 2, and 3. Okay, now we want to find the radius, so we'll call it r for now. Because r meets at a tangent, tangents are perpendicular, right? Well, let me make this white again. Tangents are always perpendicular, so we know that that angle right there is perpendicular. And we can say the same thing for this one, because it's also a tangent to the circle. And that leaves this one, which must also be a 90-degree angle. Now, if this is r right here, and this side right here is r, so both of these are r, that means it's got to be a square, right? And so all 4 of its sides are r. Now, if this whole thing right here is 5, and if this is r, that means this right here is going to be 5 minus r. Now let's call these points A, B, and C so I can reference them easier. Now AB is going to be 5 in total, and that means this point from A to where the circle meets AB is going to be 5 minus r. Then this tangent here is also going to be 5 minus r, because 2 tangents to a circle always have the same length. So this and this are equal. Okay, now let's use the same principle on the other side. We have this length right here from C all the way down to where the radius meets BC. And then we have this length right here. So both of these are going to be equal. Okay, and so we want to find this right here and put it in terms of r. Well, we have the total side length and we have r. So this is just going to be 12 minus r. And remember, we said that these two are equal, so this is also 12 minus r. And now we have what we really wanted. We really wanted this whole thing in terms of r, right? So we have 2 things combining to make 13. 5 minus r plus 12 minus r equals 13. 17 minus 2r equals 13, and r equals 2. And we're done. Now, if you want a formula so that you don't have to do this work every time you have a right triangle, it's pretty simple. Let me just erase all this first. And this formula will also work for quadrilaterals inscribed in other things, circles inscribed in quadrilaterals, I mean. And it's the following. So area equals radius times semi-perimeter. So the semi-perimeter here just means it's half of the total perimeter of the thing that the circle is inscribed in. So in this case, the 5, 12, 13, if we want to find the area, it's the base, half times the base times the height, or 30 in this case. So we'll put that in here. 30 equals, now the radius, that's our unknown, times the semi-perimeter. So the perimeter is 5 plus 12 plus 13, or 30. And so the semi-perimeter, which you divide by 2, becomes 15. So we can substitute that in, and now we just solve. So radius equals 2. And we can see that we've checked our answer.